What is the ultimate cosmic limit? The civilization was desperate. They had tried everything. Observatories spanning entire galaxies captured every wavelength of light pouring in from the observable universe. Ingenious devices probed the microscopic, the atomic, the subatomic, and finally the quantum realms. They had colonized vast swathes of the cosmos, traveling for billions of years on immense arc ships. They were the most powerful civilization the cosmos had ever known. Yet, it was not enough. After millennia of effort, they came to a staggering realization: their universe was not alone. There were infinitely many others. What they perceived as a vast, almost incomprehensible cosmos was just a tiny bubble floating in an infinite sea. This revelation did not instill fear but posed a daunting challenge. How could one measure the immeasurable? In an infinite multiverse, every statistic seemed nullified, and every discovery, no matter how grand, seemed insignificant. Their quest began in the primordial era. From humble planetary observatories to Kardashev scale achievements, they climbed the ladder of energy mastery, harnessing their planet, then their solar system, and eventually their galaxy. Planets were reshaped, stars harnessed as energy sources, and nature itself seemed to bow to their will. Yet, with knowledge came new questions. Were there boundaries that no amount of advancement could surpass? Were there secrets even a galactic civilization could never uncover? At the smallest scales, nature shielded itself behind Heisenberg's uncertainty principle. In the quantum realm, one cannot precisely determine both the position and momentum of a particle. On cosmic scales, the speed of light imposed an unyielding boundary. The cosmological horizon concealed whatever lay beyond. As the universe expanded, distant galaxies receded forever beyond reach, their light fading into oblivion. Time, too, proved to be a relentless gatekeeper. The past, once gone, remained accessible only through fragmented memories and traces left in the present. Even black holes, ultimate vaults of cosmic information, sealed their secrets behind event horizons that no light could penetrate. Even if every particle in the observable universe could be catalogued, its position, energy, and quantum state precisely measured, would this represent the pinnacle of knowledge? No. For the true nature of the cosmos is interwoven with empty spaces, quantum fields, and fundamental vibrations, an infinite tapestry that defies human comprehension. In their pursuit of the unattainable, the civilization created machines designed to think differently, hoping that these synthetic minds might reveal radically new perspectives. Yet, each machine was a reflection of its creators, a mirror that, while faster and more precise, still echoed the same unanswered questions. In an act of both despair and hope, a small group proposed a daring experiment, seeding life on a young planet. They altered the primordial chemical soup, nudging it toward the emergence of intelligence, an intelligence unlike their own. They did not know how these beings would perceive the universe or what truths they might uncover. Yet, they waited. Dormant, they dreamed of what they might learn from these new minds. Even if a civilization transcends its biological and technological limitations, one insurmountable enigma remains: infinity. A concept both mathematically indispensable and philosophically paradoxical, infinity challenges the boundaries of understanding. How can the finite encompass the infinite? And what if the answers lie beyond the grasp of science itself? The destiny of knowledge is not solely a journey toward answers but also an acceptance of the insoluble mysteries. Perhaps, at the heart of this acceptance, lies the true meaning of the cosmos. The realization of the multiverse introduced an entirely new set of challenges. How could they explore not just one universe but an infinite array? Each universe might operate under its own laws of physics, host its own unique set of particles and forces, and create entirely distinct forms of life. To probe even a fraction of these realities required tools and techniques that defied imagination. They considered creating dimensional gateways, devices capable of peering into neighboring universes. But each gateway demanded immense energy, a cost that not even their galaxy-spanning resources could sustainably support. Yet, glimpses into other universes revealed tantalizing possibilities. Some universes sparkled with impossible geometries, where time flowed backward, or stars burned with colors never seen before. Others were barren, silent voids, a stark reminder of the fragility of existence. The civilization's greatest minds debated whether these incursions were worth the risk. What if the act of observation destabilized their own universe? What if they found truths too horrifying to comprehend? As their understanding deepened, the sheer weight of their accumulated knowledge became a burden. Entire planets were repurposed as data storage hubs, their surfaces covered in crystalline archives capable of preserving the information of a billion lifetimes. Black holes were employed as computational engines, their immense gravitational forces bending spacetime to perform calculations beyond any conventional machine. But even these immense structures had limits. As they sought to digitize the universe itself, converting matter into streams of information, they realized that no storage system could ever truly capture the infinite complexity of reality. Each attempt to condense the cosmos into data stripped away nuances, leaving behind an incomplete and distorted image. They began to question whether knowledge itself was an illusion, a fleeting mirage in the desert of existence. With each passing eon, the civilization's existential dilemma grew more acute. What was the purpose of their quest? Was it merely to accumulate facts, or was there a deeper significance? Philosophers among them argued that the pursuit of knowledge was an act of creation, a way of giving meaning to an otherwise indifferent universe. Others contended that their efforts were ultimately futile, that the universe would one day succumb to entropy, erasing every trace of their existence. Despite these debates, they pressed on, driven by an unquenchable thirst for understanding. They began to explore not just the external universe but their own consciousness, probing the nature of thought, emotion, and identity. Could they transcend their own minds? Could they merge with the cosmos and become one with the very fabric of reality? In the twilight of their civilization, they embarked on their boldest endeavor yet. They constructed a machine, a device so vast it encircled an entire star cluster. Its purpose was to simulate the entirety of the universe, from the smallest quantum fluctuations to the grandest galactic formations. Within this simulated cosmos, they hoped to uncover the answers that had eluded them in the physical realm. The simulation began. At first, it mirrored their universe perfectly, every star and planet recreated in astonishing detail. But as it evolved, it began to diverge, generating new realities, new forms of life, and new mysteries. The simulation became a multiverse within itself, a fractal of infinite complexity. And as they gazed into its depths, they saw reflections of themselves, civilizations rising and falling, each grappling with the same questions that had haunted them for millennia. In the end, they realized the ultimate truth: the cosmos was not a puzzle to be solved but a story to be lived. Their journey was not about finding answers but about experiencing the boundless wonder of existence. And with that understanding, they found peace, knowing that their quest would never truly end.